My name's Elijah, and this is my agentic LLM drone. So it's completely conversationally controlled. I can give it voice commands, and OpenAI will parse it and send the commands to the drone. For example, I can say take off, and then I can give it commands like turn around 180 degrees and go up 100 centimeters. I think what's even cooler though is I can tell it to follow the man in the gray shirt. And what this will do is switch to a YOLO model, which will then allow the drone to completely follow me, going any direction, forwards, backwards, and I can even go behind this pillar, and it'll won't lose me. It'll keep tracking me. Um, and then finally, I can tell it to land. And this is completely packaged with the drone. It's a program that can go towards any drone you want. It works well with Tello because that's what I designed it, but it'll work with any drone. It's a standalone bespoke program that allows a drone to be completely controlled via voice and to follow any object, but it's best at human-like objects. So I also kind of wanted to talk about the like more technical aspect of this project. So this is kind of a diagram that describes exactly what you saw in the previous video. So the pipeline is pretty linear. So first you get voice, so whisper model in voice transcriber.py, transcribes spoken commands into text. That goes to openapi.py, which has an OpenAI powered agent with access to custom Python function calls and the toolkit in OpenAI. So then that agent decides whether to send a discrete action, so move or rotate, or a continuous tracking mode that runs until it's stopped. And these discrete actions go to dronecontroller.py, which sends direct discrete flight instructions to drone, or to skytrack.py, which uses YOLOv8 and OpenCV to lock onto a target. Um, and so also want to talk about that specific process. So as you can see here, you get a bounding box around the object that the drone is supposed to follow, and that's obviously the vision model doing that, and then that allows the whole pipeline to make various calculations as to what where to move forward, backwards, or stop. Uh, yeah, and I also wanted to add this slide. I thought it'd be interesting because these were the largest roadblocks I faced during the project. So the first and foremost was multi-threading. So I ended up having to run 5 simultaneous threads, for tasks just like sending a heartbeat to the drone so it wouldn't automatically shut off, all the way to sending continuous movement commands during the follow mode that so we're updating every couple milliseconds. Yeah, and this was a beast. Definitely the most rewarding part of the project, but just getting like my 10th seg fault on drone shut off and trying to fix that was definitely a struggle. So the second one was figuring out smooth follow. So just like getting the right variables, so movement wasn't overcompensated and the target wasn't overshot or undershot, which required a lot of tuning, acceleration, that kind of speed and acceleration, that kind of thing. And so third was the vision model choice, which was definitely a big part of the process. So I first used OpenCV's built-in tracking methods, but they're definitely lightweight and fast, but they really struggle with occlusion and long distance reliability. So it was a godsend to find YOLO V8, which definitely offers more robust detection and allows for reacquiring of the target after loss. Yeah, and yeah, I mean, overall, this was an extremely rewarding project to work on, and I'm really excited to work on a drone which has more input capabilities like LiDAR, GPS, to allow for a larger variety of tasks. So that's definitely the next step for me. So that's my autonomous AI powered drone. If you want to talk about it, feel free to reach out on LinkedIn, and if you want to check out the code base on GitHub, the links are in the description and on the screen.